Hello and welcome to today's lesson. Today we are talking about angles of elevation and angles of depression. So if you notice this person sitting here on the top of this cliff, this person has eyesight that goes straight out. So if you follow their eyes and they go straight out. Now their eyeballs can look up so that they're looking up to that airplane, and this would be called the angle of elevation. Now, following that path, their eyeballs go straight out, and now their eyeballs are now going to look down at the ship. So this is the angle of depression. So both the angle of elevation and depression have to take that horizontal look, that your eyes are looking straight out. Your eyes are looking straight out. And now, do they follow a path of going up for the angle of elevation or down for the angle of depression? All right, so that angle of elevation is the angle formed by the horizontal line. That's where I'm talking about your eyes. Your eyes go straight out horizontally, and the line of sight above the line. So you're looking straight out, and your eyesight goes above. So this is what would be considered an angle of elevation. And then your depression is going to be just the opposite of that. The angle formed by the horizontal line to a sight below that horizontal line. All right, so angle 1 and angle 2. So if you look here, we got the monkey's eyes. His eyes, are going straight out. Now, as he looks down, that's why this is considered the angle of depression. Now, in the tower, their eyesight goes straight out, and now they look up to the monkey. So this would be considered your angle of elevation. All right, so take a moment here, pause it, and then you practice. What are these angles? 3, 4, 5, 6, what kind of angles are they? All right, so if we take from here and we go straight and then down, 3 is going to be depression. All right, now if you look at the hiker here, his horizontal is right here, and now he's going to look up. So 4 is elevation. And 5 is going to be, angle 5 is going to be depression. Angle of depression. Now, if you're at this tree, I don't know if the tree has the eyesight or what, but you have here, and then now we're going up. So the 6 would be the angle of elevation. From the horizontal line, it's going above, so it is elevation. All right, let's put a few of these to good use. So on your test, you're going to need to draw some pictures and then go ahead and set things up. So an air traffic controller, so person standing on the ground, he sights a plane at an angle of elevation. Okay, so his horizontal view, and then now angle of elevation up, this angle of elevation is 41 degrees. The pilot reports that the altitude, so this altitude, so if this is the airplane, we all know how great of a drawer I am, so here's your airplane, is at 4,000 feet. What is the horizontal distance between the plane and the airport? So the air traffic controller is at the airport, and he has an angle of elevation, so when his eyes look straight out and then up, so the angle of elevation here is 41, and they want to find the distance between the plane and the airport, so X. All right, so from 41 degrees, we have opposite and adjacent. So this is going to be the tangent of 41 is opposite over adjacent. And remember how we solve these is these guys just basically change places. So we are going to take 4,000 and divide by the tangent of 41. And I am getting 4,600, and they said round to the nearest foot, 4,601 feet. All right, read this one, set up a diagram that you think it should be, and then set up, and then turn the video back on so that you can see if you did this correctly. All right, Forest Ranger. All right, he is in a tower. This tower is 90 feet. All right, so they look straight out, and then they look down, and they see this fire happening here. Okay, the angle of depression, so straight out and down. So this is where your 7 degrees is. And they want to know what this horizontal distance is. Now, if we call this X, because this is going to be the distance from the tower to the fire on the ground, remember this figure right here is a rectangle. So if that's X, this is also X, and this is 90. Because I know the 7-degree angle, I'm going to go the side opposite and adjacent. So I'm going to set up the tangent of 7 is opposite over adjacent. So I am going to take 90 and divide by the tangent of 7. And I get 730. Again, they want to know nearest foot. So 733 feet. All right, last problem. So please stop the video, give this one a try, and see how it goes. This one's a little bit more complicated, but there is definitely one like this on your test. So give this one a try and see where you are at. All right, a pilot flying. Okay, so we got the airplane, our nice fancy airplane here. Okay, he sees or she sees. Okay, and they're at an altitude of 2.7 kilometers. That's how high off the ground they are. All right, so, oh, it is a her. The angle of depression to the base of one tower. Okay, angle of depression. So when we go straight out, and then when we go down, so this would be our angle of depression. This gets us to a tower, the base of the tower. So tower 1 is going to be right here. So we have this right triangle. We know this is 2.7, and this angle of depression is 37 degrees. Okay, because there's another tower, I'm going to call this one X. When I go all the way here, I'm going to call this X, so that length. So if I set up the tangent of 37 is opposite 2.7 over X, this total distance here. All right, so 2.7 divided by the tangent of 37, and I'm getting 3.6. So X is going to be 3.6 kilometers. All right, the angle of depression of base to another tower. So if I have another tower and this base right here, they're saying now this angle isn't 37, it's a bigger angle. So if it's a bigger angle, it's going to come down here. So this angle is 58 degrees. All right, so now I'm going to call this, focus on my red triangle here, and this one is going to be 58 degrees. So if I now, this is going to be what, tower 2, did I say? Tower 2. So if we had this going straight up, okay, that's still 2.7. That has not changed. There's the plane's still 2.7. And now this distance right here is my y. So now I'm going to find my y value. So this time I'm going to do the tangent of 58. So tangent of 58 is going to be opposite 2.7 over, and I'm just calling it y, so we have two different values here. So now we're going to do 2.7 divided by the tangent of 58, and I got this one to be 1.7. So y is 1.7. What they ultimately want to know is what is the distance between these two towers? How long is this between the two? Well, if we take x value and subtract y value, so if we take 3.6 and subtract 1.7, so 3.6 minus 1.7 should give us 1.9. So the distance between the two towers is going to be 1.9 kilometers. All right, good luck on this homework with the angle of elevation and depression.